Hello everybody, today we're going to take a look at what happens when a single array or a single list just isn't enough. And we are going to go and do a totally new project for this one. So let's go ahead and just keep it fresh. I wanted to keep from doing the same projects over and over again because I think they can get a little convoluted. So 2D arrays are kind of hard to understand as is. And this 2D arrays are just the beginning. There's actually multiple dimension arrays, but let's look at what's going on here. And so we just have a basic form, right? And at some point we're going to have to put a button in there, I suppose. So let's go ahead and do a button, drag a button on here. I have no idea what we're going to do with it because we really just want to demonstrate the arrays. Now, let's think of it. Let's say you want to represent something as a table, not just as the same numbers. So in the past, we talked about a DVD list. We talked about grades from the same person. What happens if we want to do a table? It's like a lookup table where, let's say, you want to find information about somebody. So, you see their first name, you see their last name, and some piece of identification. Let's say it's a customer number. How would you do that? Well, you could do it one of two ways. Like I said before, we're talking about two-dimensional arrays, but it is also something that's called a parallel array. And let's go ahead and go into button one, and let's call it find info for now. And we can keep it button one. We can always rename it later. I don't even know what we're going to plan to do with it, but let's go ahead and click into it. So as you can see, we get this brand new fresh piece, and we can create an array. And if you guys remember the arrays, it is as the following. Say int, that is going to be a single array, and we'll call it first name. Maybe we should call it big N. Do one of the proper types of naming conventions. Set it equal to new int, and then let's give it something big, like 100. So we can put 100 names in here. Who knows? Let's say 1,000. Might be overkill, but using up 1,000 spaces is not a big amount of space to use, so we're okay. And we could do the same here with the last name, right? And this is what's going to be referred to as a parallel array. If you have somebody named John Doe, we'd say first tab name, 0 is going to be, oh, why did I call it ints? Let's call these things strings. That's a little crazy. Let's rename the string. I guess I always want to do ints because they're so easy and simple. There we go. And so we could say first name 0 equals, and I forgot what the name is, we'll just make it up, John. And then the last name 0 is going to be equal to Smith. In each 0 space is going to be the information about John Smith. So in other words, even if we put a third one, let's say call it string. Actually, now we could do this. Int customer number new int, and then if I made a customer number for John Smith, it would have to be in the 0th place, right? So everything aligns. And because of that, that means everything here has to be the same length. because you wouldn't want to have this as 999, because then if you hit your technically your 1,000th customer, he wouldn't be allowed to have a customer number. So let's just go ahead and put this number in there. He's 1002036. And so you could populate this array as you see fit. But you could also do what they refer to as a two-dimensional array, where instead of having to always worry about where this customer number is or their index of this customer, so John Smith's index is 0, you know, Sally Jones might have the 7th place or something like that. Who knows? And then you have to align all those. But you could go with something like a two-dimensional array, as I said, and we'll call it string. And this is the issue with it, because as you can see here, and we'll call this customers. Customer, actually information. And then make it, well, we have how many rows and how many columns? Well, in this case, if you look up here, if you think about these as columns, you essentially have 3 columns. But in those columns, you have 1,000 rows. So you say something to the effect of 1,000, 3. Meaning 1,000 from here and 3 from first name, last name, customer number. 3 items there. And this is going to naturally order them. Now, what's the problem here? Well, if you notice, I had to do string for all 3 of these because it's an array. Arrays like everything the same. If I want parallel, I could do string int, which is definitely an advantage. Not terrible, because remember, we can always take something and put it into a string, and we can take something from a string and turn it into a number. That's not a problem. It's just an extra step. Doing a two-dimensional array is nice because it is nice for organizational sake, but for functionality, parallels might be a little bit better. Because again, think of this. Let's say we don't know. Maybe we're going to build this table out, and eventually it's going to have 10 columns of information. You know, not only customer number, but address, state, zip, etc. The whole shebang. And in fact, it might go out to 20. Well, we can just build these things as we need them in the parallel array and then show them off. In this array, we actually have to expand. And then you might have a bunch of blank places. And in fact, this can get large pretty quick because the amount of spaces on the card that it's going to take is going to be 3 times 1,000. And like I was saying, you can do multi-dimensional arrays in a lot of programming languages. So in other words, it looks something more like this. Well, now you're multiplying 1,000 times 3 times 5. So that's 15,000. And if you put another one out here like 3, again, doesn't seem like a big number, but it's 3 times 5 times 3, which is 45,000. So these can build up and take up a lot of space quickly. So you have to use them judiciously. Now, how can we display them? You know, just your standard list boxes if we wanted to do that. So let me just drum one of these up really quick. But first, let's stretch this out a hair. In this case, we're going to be a little bit lazy because these are going to be list box 1, list box 2, list box 3. You can keep those there. You can move them up a little bit. Put the button in the middle. Sure, why not? Now the fun part, we can just write for each. Actually, I don't think I want to do for each. Let's instead do a for int I equals 0, I less than, well, let's say 1,000 at first, I plus plus. Oops, let's put semicolon in there. And now we can just put in first, oops, list box 1, oops, dot items, dot add, first named I. And if it likes this, then we can just do that for each list box. No, I don't want number. I want customer number. Now, when we run it, we might get a small error, which is right here. And the problem here is that there is nothing after this first name 0, it's first name 1. So in other words, if I could manually do that from 0 to 1, right, and now it should work fine. It'll put it in. Oh, I put them all in the same list box. Let's try that again. And start it up. And so now you can kind of see it's a parallel array, but all that information is in each row. Now, how do we do that without getting it mad at us for these kind of empty spaces? Well, we could just initialize all of them. That would work. But in this case, I think what we'd like to do is not print all those out. So let's do an if statement instead. So if I say if, and let me get this off the line here. So what's going to get that? Well, let's do list, not list box. First name, and then I equal null, not equal to null. So in other words, something has to be in that. So if it's not equal to null, null means the absence of something, then we can go ahead and do this. Now you could say, why don't we check for last name and customer name? Well, remember, these are parallel arrays. So if there shouldn't be a last name where there's a first name and vice versa, and there shouldn't be a customer number where there isn't a last name. So if we only have to check one of these boxes in order to make this thing happen. Now let's give this a try. And voila, everything works out a lot better. Okay, so now let's talk about using the customer information. In fact, instead of using the same loop, which we could have used, we're going to just highlight it out. Not highlight it out, we're going to comment it out. And how do you fill out customer information? Well, the same exact way, if you think about it, because we say we have 100 rows and 3 columns, right? So in the first row, same exact thing, it's 0, right? So we could say customer and 0 row, 0th column, or the first column, is going to be equal to, and let's give it something. What do we say? Sally. We're going to call her Sally Jones. And since these are all strings, we're going to have to put all quotes around them, even the numbers. And so I can do the same thing again. But now if you think about it, we have to go over to the second column in order to put Smith in, if thinking back to the way the list boxes were done. So this has to be the 0th row, first column, and her last name is Jones. Lastly, we're going to do, let's see if I can just paste it. Oops, I'm pasting nothing. Then, instead of Jones, we're going to give her a number. But it's going to be in, you guessed it, the second subscript, or the second index, which is really the third column of data, and that's going to be the numbers. So it doesn't give it as unique information because this is all customer more information instead of having first name, last name, and customer number. It doesn't label it out, so sometimes it can be a little confusing there. But again, organizationally, it's all in the matrix essentially, and we can just pull it out. And again, we could use a structure just like the for loop. And we can still make it go I to 1 to, oops, 1000. And I'll have to check, we'll have to check that out. Then instead of list box add first name, we do customer info. Now the question becomes, well, what do you really want to print out here? And really it's the column, right? So the I goes here. And same thing here. We're going to just put this, and we can say, if you want to, I plus 1. Put the last one here. I plus 2. Right? So it would come in and automatically print out these. Now this is cheating a little bit, let's face it. Because what happens when I goes to 2? Then this is going to start at 0. This is going to start at 2, 3, 4. We don't necessarily want that. What we would like this to really say is I put our I here, and I here. So when it goes down in a row, it will just pick it out. And change this to 0, 1, and 2, essentially hard coding this. You could, if you wanted to get really fancy with this, you could actually make this special and do a nested loop, where essentially you do a loop within a loop. Because if you think about a nested loop, going back to that lesson, what you do is you get into the first loop, and then you get into the second loop, and the second loop has to go to continuation before you can go back to the first loop. So if you think about that, you can make the first loop rows, the second loop columns, and just spit out that specific information. But in this case, I think this will work. So let's give it a quick test, and it will pass the muster here. And again, that null did hold for that. So that's the basics of 2D arrays and 3D arrays. But for now, let's just stop there and move on to the next section.